Hello everyone. In this video, I am going to discuss the concept of fundamentals of the analysis of algorithm efficiency and analysis framework. I mean that in this topic, just I am going to discuss what are the different possible ways the different efficiency of an algorithm can be calculated, and we are going to analyze the different type of efficiency classes. So, so the main goal of this analysis and the fundamental framework is we are going to identify the efficiency of, analysis the efficiency of an algorithm, and from that algorithm efficiency, we are going to identify the best algorithm. So normally, the algorithm efficiencies can be calculated in two ways. One is time complexity, another one is space complexity. Already we know that the time complexity means that the amount of time considered, amount of time taken to execute your entire algorithm, execute the entire algorithm, or maybe find the time taken to find the solution for the given problem. Solution for the given problem. So this is the definition of the time complexity. So normally this, and the next thing is the space complexity, the amount of space required to solve the given problem is called as space complexity. I will repeat once again. The main goal of this topic is we are going to analyze the efficiency of an algorithm, and from that we are going to identify the best algorithm. So normally there are two ways that algorithm efficiency can be evaluated. One is time complexity, another one is space complexity. Time complexity means that the amount of time taken for execution of an entire algorithm to find the solution for the given problem is called as a time complexity. And the space complexity represents the amount of space required to solve the given problem, then it is called as a space complexity. So in order to evaluate the efficiency of an algorithm, there are different steps that should be considered for evaluation of the time efficiency. So these are the four steps need to be evaluated for evaluation of the algorithm efficiency. One is measuring an input size. Second one is units for measuring running time of an algorithm. And third one, order of a growth. And fourth one, we are going to represent the worst case, best case, and average case efficiencies. The first step is you are going to measure the input size. It means that just here we are going to define what is the parameter we are going to consider for measuring an input size. So whenever you are going to evaluate any kind of an algorithm efficiency, then some of the parameters need to be considered. And the first one is called, that means we need to have some parameter for indication of the algorithm efficiency. So we must to know that what is we have to define some factor for define this algorithm efficiency. So normally the input size will be act as an important parameter for indicating the efficiency of an algorithm. So always for any kind of an algorithm, we have to express the algorithm efficiency with the help of input size. So normally for many cases, we are always to represent the input size here. So that always the maximum for all the algorithm, the complexity of algorithm to be represented by n. So this is the first step. So that when we are going to analyze the efficiency of algorithm, the first step must be we are going to define the input size. Once if you know the input size, then we are going to analyze the algorithm efficiency. So further, just we are going to define the units for measuring a running time of an algorithm. So further, there are different methods normally we use for evaluation of the time. Measuring time of an algorithm. Initially, they are using the method of by using the concept of computer. Just we are going to calculate the size of your the time taken for evaluation of the algorithm efficiency. So just we are going to complete the algorithm as in the form of program, so as in the form of program, and try to find the time efficiency by finding so find timing ending time minus starting time. So எப்போ இந்த அல்காரிதம் கண்டுபிடிச்சாலும் சரி என்ன பண்ணணும் அப்படின்னா எண்டிங் டைமுக்கும் starting time differences வந்து நம்ம calculate பண்ணி தான் the time efficiency calculate பண்ணணும். So normally this method depends on RAM speed. It depends on RAM speed. So if the RAM speed differ ஆகும்போது வந்து பாத்தீங்க அப்படின்னா கண்டிப்பா the time efficiency of this method will be varied, so that variated இருக்கும், so that it varies based on speed. So that but normally whenever we go into analysis normally it will be a constant matter, so then it will not be considered as a correct method, will not be considered as a correct method for it will not be considered as a correct method for calculation of the efficiency. Efficiency calculate பண்றதுக்கு it is not a best method, because of இது வந்து RAM speed தான் டிபெண்ட் பண்ணி இருக்கும். RAM speed பேஸ் பண்ணி மாறும்போது இது வந்து கான்ஸ்டன்ட்டா இதுதான் டைம் எஃபிஷியன்சி நம்மளால சொல்ல முடியாது. ஏன்னா ஒவ்வொரு மெஷினுக்கும் ஒவ்வொரு டைம் காம்ப்ளெக்சிட்டி வரும். ஸோ தட் இதை வச்சு நம்ம பெஸ்ட் அல்காரிதம் நம்மளால டிசைட் பண்ண முடியாது. ஸோ ஃபார் தட் we are trying to find out the next method that is called as a frequency count. Frequency count means that number of times each and every instruction in the problem statement is executed. I mean that each and every instructions the statement are executed. For example, let us take one simple example for calculation of the frequency count. I'm going to take a looping statement, and I'm going to calculate some calculations. Okay, let us take this is the statement. So now I'm going to calculate the frequency count for that looping statement. So we know that so here the initialization works for one time. So now just for a loop condition, so this is the condition one time. If the condition is true, loop statement it's work for a one time, and modification part, I mean the incrementation part, will be work for one time. So if this condition is true, if the condition is true, means that there are the frequency count is 3. அதாவது இப்போ வந்து எனக்கு வந்து லூப் கண்டிஷன் ட்ரூவா இருந்துச்சு அப்படின்னா கண்டிப்பா வந்து என்ன ஆகும் அப்படின்னா 3 மீன்ஸ் the frequency count of one time loop execution வந்து 3. So totally so the loop statements are executed, means the loop conditions are true. Loop conditions are true for n times. Are true for n times. If n times வந்து நமக்கு true, therefore the frequency count for condition true என்ன அப்படின்னா frequency count for 3 into n, because ஒரு time work ஆகும்போது வந்து 3 the frequency count 3, so that it takes 3n times. So the next term is and another one more thing, so the condition false need to be evaluated one time, so it is one time extra. Therefore the total frequency time என்னன்னா, therefore the total frequency count is now also initialization one time, loop condition true and 3n times, plus condition false 1 times, so totally 3n plus 2. So this is the frequency count, but there is some drawback we have in this method. In the method some drawback இருக்கு. என்ன அப்படின்னா வந்துட்டு means if the length of the program is complicated, I mean that the logic of the program is complicated, it is very difficult to calculate frequency count. The length of the program and the logic is so much complicated, it's very difficult to calculate the frequency count. And second one, it depends on technical logics, technical information. இது வந்து technical information தான் depend பண்ணி இருக்கும். So these are the two drawbacks. This frequency method is not efficient. So then we'll go to the third method, that's the efficient method, that is called basic operation. The basic operation defines it. The operator or the operation is used for finding the solution. அதாவது எந்த ஆபரேஷன் யூஸ் பண்ணி நம்ம சொல்யூஷனை ஃபைண்ட் பண்றது அப்படிங்கறத இண்டிகேட் பண்றது தான் பேசிக் ஆபரேஷன். இட் இஸ் நார்மலி இட் இஸ் a best method. It will not depends on any technical information. So for example, here just I'm going to take the same thing. So here my objective is I'm going to find the sum of a natural number, means from 0 to n minus 1. So that here the basic operation is so for this case, the basic operation is addition. So this is that addition need to be used for calculation of your operation. So that normally it will be work for n minus 1 times. It works for n times. So that the efficiency is n. So this is the way we have to calculate the efficiency for basic operation. The basic counting the number of times the basic operation execution is the best way for calculation of the efficiency. So just I'm going to define the general. Now I'm going to define the general equation for calculation of the basic efficiency. So this is a general equation for calculation of the time complexity. That is a running time of any algorithm. That is called the time complexity for solving the input size n. It is approximately equal to COP. That is called you have to return in subscript and into C of n. C of n means that the number of times the basic operation is executed. That is called the efficiency of algorithm, and COP indicates that the time needed to execute this basic operation for one time. Time needed to execute this basic operation in one time. அதாவது ஒரு டைம் ஒரு பேசிக் ஆபரேஷன் எக்ஸிக்யூட் பண்றதுக்கு உங்களுக்கு எவ்வளவு டைம் ஆகுது, இந்த சி ஆஃப் என்ங்கிறது பேசிக் ஆபரேஷன் வந்து எவ்வளவு டைம்ஸ் ஒர்க் ஆகுது. ஃபார் எக்ஸாம்பிள் நான் வந்து கால்குலேட் பண்றேன் அப்படின்னா assume that basic operation execution, the number of basic operation execution வந்து பாத்தீங்கன்னா 5 எடுத்துக்கங்க. 5 times that is called that's a basic operation execution for one time வந்து பாத்தீங்க அப்படின்னா 5 milliseconds அப்படின்னா then the time complexity is approximately equal to this time complexity is approximately equal to 5 into 5 milliseconds. So totally the 25 milliseconds, it is the time complexity. So this is the general equation for calculating the time complexity of any algorithm. So that's a T of n equal to COP into C of n. COP means that ஒரு basic operation வந்து எவ்வளவு டைம் எடுத்துக்குது ரன் ஆகிறதுக்கு, C of n ங்கிறது எவ்வளவு number of times வந்து basic operation execute ஆகிறது. This is approximately equal. Because that the COP will be varied depending on the machines. But here, so that this is the dependable factor. So that normally the T of n is approximately equal to C of n. C of n means that the number of times the basic operation is executed. So this is the best way for the calculation of your time efficiency. So now the second step is over. The first thing is the input size is over. Second one, the unit for measuring a running time. And third one, you are going to define the order of growth. Order of growth means that if the size of the input is increased, then how much the complexity will be increased. So based on the size increase the size, we are going to define the best fastest algorithm which have a best solution. And for that we are going to compare the various factors. So for that we must know what are the basic efficiency classes we have. But already we know what are the basic efficiency classes. Normally we use one is constant, log n, then n log n, n square, n cube, n factorial, and 2 power n. That is called exponential. So these are some of the basic efficiency classes we have. So that just we are going to assume that there are two solutions. I have one solution is n square, another one solution is n cube. Just I am going to predict which is the order of growth. Means if the size of the value n increase, and we have to identify which is the factor have a more time complexity. So n cube is the more time complex, the highest order of growth. So that we have to define here n squared is the lowest time complexity, and I have to select this the solution which contains the complexity n squared is the best solution for algorithm efficiency. And the next term is I'm going to define the efficiency of an algorithm. So that there are different factors. We are going to consider for algorithm defining the algorithm efficiency. One is worst case efficiency, best case, average case. So worst case efficiency means that the algorithm takes the longest time for solving the given input size. So normally it will be represented as C worst of n. So this you have to define in subscriptor. C worst of n, that is called the complexity for solving input size n. And the best case means the algorithm takes the lowest amount of time for solving your input size n. That indicates as a best case. And average case means that the algorithm takes the average time for solving your input, that is called average case. And there is another one more efficiency also we must to know about that. That is called as amortized efficiency. Amortized efficiency means that the one means that for example that the algorithm takes longest time for the particular operation than the total time. The total time efficiency is better than its worst case. Then it will be coming under amortized efficiency. It takes the longest time for the particular operation and the total efficiency time is better than worst case. Then it will be coming under amortized efficiency. For example, if you want to solve a binary search, the basic condition is we have to make a list of elements either in ascending order and descending order. So for that, if you want to, then you are going to perform a binary search. But here for a sorting, we need approximately the best case of that n log n for a merge shard, or it may be a heap shard. And next thing is for a searching, we need a big O of log n value. So, but here see that for a sharding, the longest of it takes the longest time. But it is the best. Means that that is for in a linear search, the worst case is n. But here in the binary search, the complexity is log n. So that the total time complexity is better than its a worst case of the linear search. Then it will be coming under the amortized efficiency. Just I can repeat once again. In order to analyze the algorithm efficiency, first of all, we must know what is the input size we are going to use. Second one, what is the methodology we are going to calculate for a calculation of the running time of an algorithm. Next one, if you have a more than one solution, just we are going to identify the best order of growth, which contains the algorithm which takes the lowest order of growth. And the next term is we are going to define the best case, worst case, and average case efficiency for the algorithm. So these are the four basic steps need to be formulated or maybe to be followed in order to define the efficiency of algorithm. Thank you.